We're going to find dy dx using implicit differentiation. In the last video, I talked a little bit about the difference between explicit and implicit relations. Here are a couple of examples of explicitly defined functions and implicitly defined functions and relations. But I'll make sure that a link is popping up on your screen right now to take you back to that last video if you'd like to review. As for our problem, we're going to find the derivative of this equation with respect to x. As far as this cosine of y term goes, really what we're doing is we're taking a derivative of a function. It's a cosine function, but inside of that cosine function, we have some function of x. What we learned with the chain rule is that we start with the outermost function, or the cosine function. We take the derivative of cosine, which is negative sine, but then we have to multiply that by the derivative of the inner function, in this case, x cubed. That's what the chain rule says. For our example, we're taking the derivative of a cosine function, that's negative sine. Then we have to multiply that result by the derivative of the innermost function. Well, the innermost function is y in this case, so that gives us the derivative of our first term. For the second term, we have sine of x, and we're taking the derivative of that with respect to x, so that is simply cosine of x. For our last term, we're taking the derivative of 5y with respect to x. We can pull that constant 5 out, and then the derivative of y with respect to x, well, we don't know what y is, so it's just the derivative of y with respect to x. Now let's rewrite these derivatives with a more standard notation. We can write the derivative of y with respect to x as just dy dx. And that's what we're trying to find in this example. What we can do now is isolate dy dx algebraically. There are a couple of ways to do this, but I'll start by adding this sine of y term with the dy dx on it to both sides of the equation. Then on the left, we're left with just a cosine of x. And on the right, we have a 5 dy dx plus a sine of y dy dx. Now that we have all of the terms that have dy dx on them on the right side of the equation, you'll notice that we can factor dy dx out. Factoring a dy dx from the first term just leaves us with a 5, and factoring the dy dx from the second term leaves us with a sine of y. Now getting dy dx by itself is just a matter of dividing both sides of the equation by that expression in parentheses. Now we have dy dx equals cosine of x divided by the quantity 5 plus sine of y. And now I believe that that is our answer. I'll zoom out and make sure that they don't ask us for anything else. I think that's it. We just needed to find dy dx, so that is our answer. I hope that this helps you out with your implicit differentiation. I'll see you in the next video, where we'll do a problem from the next section.